experiment 2 that we had completed, or we already have conducted this experiment last week, and some 6 of us, or 5, 7, some of our students attended the session, and that was the first session that we started, and it was fun. It was fun actually to have. Lab is always fun when we can do it face to face. All right, I'm here. If you can see, oh, it should be. Blur my background. Yes. Okay. Okay, so that was our first lab session, and then not first, but face-to-face session. All right, so let's go to that experiment and spatial precautions. So when we
ये चल रहा है, उठो, पीरियड का टाइम हो गया, ऑन करो.
Okay, so if that we said in our lab report marking scheme, right, that all the lab reports should come along with the risk assessment, so that we know or we understand that student or participant already had considered the risk. So for this level report as well, you have to report, you have to mention the risk assessment form, and you may expect, anybody would expect that the lab risk assessment for this lab will be very detailed, but I don't ask you to do it a very detailed way. You can tell us what could be the risk associated for this conducting this lab, since there are so many chemicals that we had handled, right? So many chemicals we had handled here, and there were strong acid, strong base, they are carcinogenic, and metal oxides, and so many things there was there. So I don't ask you to categorize all and every, but be smart to to point out those who are very prominent, like strong acid or base, or the very hazardous and carcinogenic, some of the chemicals that we gave you, or the gas came out, or the fire could be the fire, all those things. You just list down. You don't have to be very, whole 1 or 2 pages, as long as you can point out those, the risk that were, the chemical mainly posing the risk. And you don't have to be worried about the plagiarism, because I believe all those 7 or 8 groups that we have in our lab, they all will have their own way of putting the things in their own sentences, right, in their own language. So when they are putting it in your own way, it should not be matching with others. So there will be no plagiarism. And hopefully there will be no plagiarism. Of course, there, the HCl, sulfuric acid, carbon dioxide, those things will be matched. But when we see that there is a lot of match in this report, we go right into that report to see where the matching coming from. Like the student has taken the whole paragraph from someone else, right? Or whole, it is just a copy and paste from someone else, the whole thing. So then we go and check and say, okay, this student did not do good, so they are not going to get the, it will not be, the marks will not be appreciable. Okay, so this is one thing. Second is introduction. I don't ask you to do introduction, but for this lab report for 2, okay, lab report experiment for 2, you don't have to do any, the methodology. You don't have to do any methodology because there are so different experiment we have done in this lab that we cannot probably, it will be very hard to do the methodology. So you don't have to do, you are exempted from doing the methodology. You can write away because the discussion, result and discussion is quite much here. So you can right away jump into that result and discussion. The results are what you got for this here, whatever results, because the color of the solution was not provided. So it's all nil, blank or nil, and ion responsible for that color solution. So for copper sulfate, we know that copper will be divalent, sulfate is divalent as well. So copper will be the main culprit or main thing that is causing it to be blue. Same goes for manganese chloride or potassium chromate, dichromate, all those things. So for this case, maybe it is not potassium, but for probably for chromate or manganate, all those things are the main reason for different color. Whereas these places, they are the metal ions, they are more responsible for. Maybe I'm just giving an example. I mean, you of course you should look into the book and try to find out what. But for information, just to make it easier for you, that the color solution appears because of the transition of the electrons at the outer shell, right? So when it is there in the outer shell, that means the element has more electrons or more way to organize the electron on its atom, has different, can show various color. So for this case, you can relate it to the transition element, right? Transition metal, because metal, they have d orbital and they have different way to organize the electrons. So that probably they can, that is why maybe they shows the different color. And of course, when there is water is there, the water plays a role to some extent. The water molecule is associated, not the water, liquid water, the water molecule is associated. So they play a role somehow to with the water, the color, okay? And all right, this is the hydrolysis of salt. When you dissolve that salt, right? When we dissolve that salt, what is the pH we expected, or what is the pH we got? I know that we haven't discussed about the acid and base, but we all have the fundamental understanding of what is acid and base, right? Acid that gives the electron, proton, and base that receives the proton, or acid receives the electron, base gives the electron. So this is our understanding, or how do we differentiate or identify acid and base is acid makes the litmus paper red, and base makes the litmus paper blue. So this is how we understand, indicate. So based on the indicator, we would know what is the pH, what could be the pH, or what range of the pH could be. It's more than 7, less than 7, or for this case, I remember that experiment 2, we gave you the indicator that can identify what pH range. So based on the color, you can put the pH range from 4 to 5, 5 to 6, 7 to 8, 10 to 11. In that way, you can just put it here. That will be a result. We haven't gone to the discussion yet. All right, precipitation reactions. So reacted with what, and then whether there was a precipitation or what color of the precipitation. And if there is a precipitation, what was the ionic equation involved, right? Ionic equation we have already seen. Silver nitrate, for example, silver and nitrate. And sodium phosphate is here. So sodium, of course, sodium is always 1 valence plus, and yeah.
Dr. Irene?
Sorry?
Dr. Irene?
No, Dr. Irene is in. You can give to the office.
Office?
The office. Yeah.
Okay, thank you.
Okay. So sodium is always 1, but phosphate, they will have 3 valence, right? 3 negative charge. So in this case, how do you write the ionic equation? Just follow this one first, the first one given. So follow this ionic equation and prepare all those that we have conducted. If some of them are not available or we did not do in the lab, then we don't need to do it. And of course, this is what was happened here, whether there was a precipitation or no precipitation. If there was a precipitation, what type of precipitation was there, what color of precipitation was there, or if probably it is not very clear precipitation, but just a cloudy solution, right? A very muddy, cloudy solution, you can also mention that way. And later on, do this equation, okay? This is the equation number 1. This is equation number 1, white precipitate. What is the happening, the equation? Sodium carbonate you are adding with, what is that? Place and drop silver nitrate and sodium carbonate you are adding, 2 of them. So what is the precipitate is forming? And then with that you are adding another nitric acid. So what is the reaction occurring here? In that way it will go continue. All right. So please you have to write this one in the discussion, not here. On here in this table, you just have to mention whether what type of precipitate, whether there was precipitate and what color of precipitate, or just cloudy or whatnot. Okay, and here as well the evolution of gas, sodium carbonate and sulfuric acid, whether there was a gas or something came out. And the litmus paper, potassium dichromate, how does it change? Did it change the color or not? So those things you need to mention here. Thermal decomposition, the lead nitrate was decomposed, and then what happened? How did you understand that this thing happens? So in this conclusion, before this conclusion, you can write the discussion, right? In that discussion, the best way of doing the discussion will be that when you're writing the report here, you add the discussion, just write beneath that table. So discussion for table 1 should be here. Discussion for table 2 should be here. Discussion for table 3 should be here, because all of them are different. It's not related to one another. So you can do the discussion later on. I mean, just separately. And the discussion for this table is here, and you can write the equation and what involved and what of the ions involved in that equation, how the precipitation or why the precipitation occur and why did not precipitation occur. All those things you can put here just after this, right beneath this table. Same thing goes here as well. Okay, so this is the thing that. And for unknown, there are 3 unknown given as far as I can remember, that it was one silver salt, another sodium bicarbonate, another one is probably barium. So which one is what? What is A or B? The code was given A, B or G something. So which one is what? Okay, so yeah, that is the thing that you will be doing in the discussion. For your consideration or for your understanding, you may refer to this table as well, that which one will produce precipitation and which one will not produce precipitation. Here is the detailed one in discussion. So this thing probably will be helpful when you do the discussion, that you did not see a precipitation, but you are expecting a precipitation, but he did not do the precipitation. So why there is a due to this solubility rule or this from the information on the table, the thing was precipitated or not precipitated. But sometimes that it did not precipitate. You are supposed to precipitate according to this table or according to our understanding, but it did not precipitate. So what could be the thing that, what could be wrong? What, I mean, the thing that might be problem was the precipitation was so small amount, but the solvent, the liquid phase was very big. That's why it was dissolved again. Maybe it was dissolved again. So it could be, that could be happen. Okay, so this is basically what you should be doing in the lab report preparation. And it is not much. You don't have to do one page of discussion for every table, as long as you point out what's happening here, that the color is responsible for this, and why is the color responsible for this, how the color actually are occurring, or why do you see the color, and why, what type of ions are responsible for the color. And for example, you don't have to mention manganese, calcium, nickel, silicon, all those things. You can just point out few of them, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12 or 13, you can just point out, okay, 5 or 6 is good enough. Okay, so that if you take 5 or 6, those are very colorful, maybe, or not colorful, and those one. And another group takes another 5, so it will always not be the same thing among the groups. And that is why you need the group cooperation, intergroup cooperation. Okay. And yeah, so this is the same thing actually. I was saying that you don't have to do the whole discussion, the whole pages of it, just mention as long as the main points of it. Okay, so this is the thing I had to say for your lab report preparation for this experiment 2. Is there any question so far? Any question? Oh, okay, another. Hey, I mentioned on the, I announced actually on Canvas to share your result to the other groups, right? I think some group did not share to other group, and I got that notification that some group did not. So that please share. I mean, don't keep it with you till the last, and that is not a fair practice, and it is not an honest one, not ethical as well. So don't keep it until that, because your friends, they are supposed to come to lab, but they probably are not here, or they cannot come somehow. That's why they are not joining or attending the lab. Otherwise, they would be here. They would have their own result, right? So please share your result if you have with your friends, the other groups. All right, Clarence, sir, can I do the theory for it? What do you mean? What is, what do you mean by can you do theory? I don't understand. So we don't need to include the theory and the procedure for the experiment. No, I said no need for this experiment too. You don't need to do the methodology as well. And sir, the methodology is not correct. But if you have already prepared, just submit. I say that it is not required. That means it is not a sin that if you already written and then submit, I will not deduct the mark. Okay, I say for your convenience, I say it's already big, it's already long, the report. So you don't have to, if you have not done it, then no need to do it. Okay, so Clarence, I think I got then the, yeah, you don't have to do the theory, but if you want, of course you can, you are welcome to do. All right. Okay, good. Now, I want to move to that our discussion for assignment. I start recording. Sir, do we have test 1 this week? Because according to the unit outline, no. Oh, I forgot to announce it. Our test will be on, wait, let me see. On Friday, right? So this is Friday is 2, and second Friday it will be on 9th. Yes, it will be on 9th April. I'll announce it on Canvas. Don't worry, I will announce it. It will be on 9th April. Our the test 1 will be on 9th April. It will be take home test, or you know, it will be available for some time, and then you have to upload the result. I mean your work. And what else? Okay, so is there any other thing? No? Okay, so but then I stop recording here for the lab. Okay.